Exploring the Foundations and Applications of Ontology by Dave Marsland of Cardiff Theosophical Society. Ontology, a fundamental branch of metaphysics, concerns itself with the study of being, existence, and the categorical structure of reality. Rooted in philosophical inquiry, ontology attempts to answer profound questions about what entities exist and how they can be grouped and related within a hierarchy. The foundations of ontology are deeply embedded in classical philosophy, notably through the works of Aristotle, who first systematized categories that delineate different kinds of beings. In contemporary times, ontology has transcended its purely philosophical origins to become an essential framework in fields such as complex science, information systems, and artificial intelligence. The historical foundations of ontology date back to ancient Greek philosophy, where thinkers sought to understand the nature of reality by categorizing entities into distinct classes. Aristotle's categories laid important groundwork by distinguishing between substances, entities that exist independently, and accidents, properties that depend on substances. This early classification provided a systematic approach for analysing existence based on intrinsic characteristics. Later philosophers, like Immanuel Kant, further refined ontological discussions by emphasising the role human cognition plays in shaping our understanding of being. Ontology thus evolved from abstract metaphysical speculation into a rigorous inquiry driven by logical analysis and conceptual clarity. Modern ontology incorporates formal logic and computational methods, which enable more precise modelling of knowledge domains. In computer science, ontologies define explicit specifications for conceptualizations, structured frameworks that represent knowledge as sets of concepts within a domain along with their relationships. For instance, ontologies are used to organize information in semantic web technologies, where data is linked through well-defined vocabularies, facilitating interoperability between disparate systems. This formalization allows machines not only to store, but also reason about complex data sets effectively. Consequently, ontologies have become critical tools for enhancing search engines, natural language processing applications, and automated decision-making processes. Beyond technology, ontological principles influence disciplines such as biology and social sciences, where classification schemes are vital for organising empirical data systematically. In biology, taxonomies reflect underlying ontological assumptions about species and their evolutionary relationships, while social sciences utilise ontological frameworks to analyse structures like institutions or social roles that shape human behaviour. These applications underscore how ontology serves as both an epistemic guide, shaping what kind of knowledge can be obtained, and a methodological instrument aiding researchers in constructing coherent models reflective of real-world phenomena. Despite its broad utility, developing effective ontologies presents several challenges, including achieving consensus on definitions within interdisciplinary contexts and addressing evolving knowledge landscapes dynamically over time. Moreover, there remains ongoing debate regarding whether ontologies should strive for universal applicability or remain domain-specific tailored tools reflecting particular perspectives or purposes. Nonetheless, advances in collaborative platforms enabling shared development efforts alongside improvements in automated reasoning continue to enhance the robustness and adaptability of ontological systems. In conclusion, exploring the foundations and applications of ontology reveals its dual role as a philosophical endeavour aimed at deciphering the essence of existence and as a practical methodology instrumental across diverse scientific fields today. From Aristotle's initial categorizations to sophisticated computational models underpinning modern artificial intelligence systems, ontology remains pivotal for structuring knowledge meaningfully amidst increasing complexity. As interdisciplinary research expands further into uncharted territories, requiring nuanced understanding frameworks, ontology will undoubtedly maintain its central significance, bridging abstract theory with tangible real-world implementations.